the Catalyst Cloud was born out of pain. That's it, to put it in a simple way. It was born out of pain because we were doing amazing things outside New Zealand with other cloud providers. And when we had to run systems in New Zealand for whatever reasons customers had, we could not do infrastructure automation. We couldn't do software-driven infrastructure. And that's what led us to the creation of the Catalyst Cloud. And the fast uptake from customers and projects that are now running allowed us to invest more and more on the Catalyst Cloud in terms of its infrastructure, and it's part of what I want to share with you today. People think that the number one reason customers come to us to use the Catalyst Cloud is data sovereignty. I also thought that back in the day because many of our initial customers were government agencies that had to keep the data in New Zealand. But it turns out it's not. The biggest reason why people come to us today is this. It's network latency. And it's not network latency for the sake of network latency, but because if you have your systems hosted close to where your customers are, you are able to serve them better. Your response times are faster because we don't have that round trip latency affecting every single request. So this is a thing, probably a familiar map for you. This is how New Zealand is connected to the internet. We have a cable going to Australia, another cable going to Hawaii that eventually lands in the United States. If this section A of the cable is down, then it means we'll probably take this path or potentially this path, depending on routing. And why does that matter? The reason that matters is because latency has got a profound effect on the maximum throughput of TCP, right? And ultimately that translates to response times to your customers. So this is latency in milliseconds, and this is the throughput. Within New Zealand, you should expect something between 5 milliseconds to 15 milliseconds of network latency, right? So let me get the worst case here and show you the maximum throughput we may be able to obtain. Now, if you go to Australia, you're probably getting something like 33 milliseconds to 36, sometimes 45. So that's the maximum throughput you should expect, and that's your performance drop. And now if we have to go, big route all the way to the United States, that's where the maximum throughput is, right? So sometimes we find that websites are really slow to load in New Zealand. Now you know why. There is a lot of market research on this, and one that I like in particular was done by the Aberdeen Group. And what they've done is to take 160 companies and on purpose introduce a 1 second delay in the page load time and measure what that means for their business. And the reason I like this one is because they were one of the few people to quantify that impact financially, right? And what they have found is a 7% loss in conversions. What conversions mean? If your website is selling something online, it is converting a sale. If you have a web application, it is people using your web application in the way you expect. And what they have said is, in dollar terms, if your site typically earns $100,000 a day, this year you're losing $2.5 million. And that's 1 second, a 1 second delay, right? There is more research that is available on the internet from big companies like Google, Bing, Walmart. The Walmart is really interesting because the blue bars here represent the page load times, the population, and here the page load times between 0 to 1 second and 1 to 2 seconds. So this is your conversion rates when it takes 1 second to load the page, and here's how much they sell as soon as the page takes 2 seconds to load. So what I have found that is really interesting is that people that take their digital strategy seriously and have an important online channel for their business, they are actually carving milliseconds out of their page load times to increase their conversion rates. And people that work for companies like Google, they are doing this all the time. That's why you get 10 search results and not 30 when you search for something. Now, the second reason why people come to Catalyst is because we started our organization as a web application, a software development company that was then managing or operating critical systems, and then we introduced cloud computing. And what that means is that people can get that end-to-end services from Catalyst. We had a few customers saying, it's really hard for me when I'm using other cloud providers to find people that understand how to extract all benefits from that cloud infrastructure. And when I come to Catalyst, you guys can develop the software for me, you can run that on your cloud, and I can see people face-to-face and interact with them, right? And we have about 180 people in New Zealand that are ready to interact with you face-to-face in Auckland, Christchurch, and Wellington. All our offices have cloud engineers available for you to interact with, by the way. The third one is it's an open standard, right? OpenStack was born to some extent out of that pain of there is no open standard for cloud computing. If I use this cloud provider and integrate too deeply with their cloud offerings, I have a lock-in, and trying to move to something else will be extremely hard. And what OpenStack effectively became is an open standard for cloud computing, where you know if you integrate your application and use the OpenStack API calls and someone else is running OpenStack, you can freely move between providers. Now, you may ask, who's using the Catalyst Cloud? Well, there are about 250 projects using the Catalyst Cloud. I cannot tell all customers that we have in there, but I'm allowed to mention some of them. There are a lot of government agencies in there, from small agencies like Careers to large ones like Land Information, Ministry of Education. On the private sector, you know, everything from small startups to people that are doing really I think changing the New Zealand market in terms of how things are offered like ActionStep, like CloudTech and Dragonfly, who is here today, to people like Spark, SMX, Māori Television, hosting their production website there. So you have everything from small development environments, you know, the cheerful test environments that will spin up test machines only for the duration of the test and turn them down. Because after all, you don't need your test environments all the time, do you? 24/7? Now, on the previous Auckland breakfast we had, a lot of it was about this, right? Because back then, a year ago, the Catalyst Cloud was all about paving that foundation of infrastructure services. So automating our data center and exposing that back to you as building blocks, components that you can combine to create your own solutions. So this is what on the infrastructure service space our service catalog looks like nowadays. You will find things like identity management, access control, cost management. On the compute side, you have on-demand compute instances and the imaging service that allows you to upload your own software, your own operating system to the Catalyst Cloud. For storage, you have block storage, which is storage for servers like disks, virtual volumes, or you have object storage, which is modern internet scale storage for web applications over HTTP. And on the network side, finally, you know, your usual network subnets, routers, VPN, security groups, which are akin to firewall rules, and direct connectivity to our data centers. Now, what changed, and this started about a year ago, and we've got some of that covered in the last breakfast, is that once that infrastructure foundation was there, what we started doing is to start working on these higher layers where you can use, you know, an abstraction layer like cloud orchestration to drive your infrastructure, for example. And what I would like to do is to do a quick demonstration of cloud orchestration because it's a service that illustrates all the infrastructure services working at once. So it's a good way for you, if you have never seen the Catalyst Cloud in person, to understand where we are at with our services right now. So the scenario here is, imagine you have an application that you offer yourself to your customers as a service, and they go to your website, they swipe potentially a credit card, and they say, I would like to consume your services. So you trigger something that will build that application, and you get back to them saying, here's your application. So in this case, you have an empty data center. This is the network topology view of your own private data center in the Catalyst Cloud, and it's empty. Public network, private network, that's it. And I'm using deliberately the cloud APIs to trigger an API call that is saying, launch a new content management system. It could be a payroll system. It could be a customer relationship management software, right? So as soon as I do that, that template describes all the infrastructure components and software components required to build my application, and the cloud will work through its dependencies to build everything you need to run that web application. So if I go back to my network topology view, where you had an empty data center, you now have a web server and a database server, in this case for running the Drupal content management system. So these templates, they are very simple. They this is what they look like. You have a description saying what they will do, inputs, like how big is this going to be, small, medium, large. You have actions, like launch a server, install this software, do something, and an output. For example, you probably want, in the end of this example in particular, a URL that says, your application has been launched, go to this place to use the Drupal content management system. So if I go back to that application stack, and I click on Overview, you'll be able to see the outputs from that template, and one of the outputs is a URL. And when I go to that URL, you have Drupal, vanilla Drupal out of the box with some access restrictions in place. So this whole demo, I have shortened it a little bit in the interest of time, but this whole thing took 5 minutes to launch, the complete web application. And I think this is unique in New Zealand. So far, we haven't seen other providers capable of, under the umbrella of the same cloud service, putting together all these infrastructure components and now exposing to you something that orchestrates and allow you to deploy applications in this way. Now, the next thing that happened on the Catalyst Cloud since the last breakfast, and actually, this happened today. It's available on the Catalyst Cloud as of today. Customers came to us saying, look, your cloud is the ideal environment to run modern web applications. The cheerful applications that were designed for the cloud were designed for horizontal scalability and infrastructure automation. But I have enterprise legacy applications that I need to run side by side with them, and it will take me some time to move towards native cloud computing with these applications. So how can I do that in your cloud environment? And what we've done is to partner with Provoke Solutions to offer Windows Server on the Catalyst Cloud. So effectively, Provoke Solutions has built a Windows image, and they are selling that image and supporting that image on the Catalyst Cloud. And I would like to show you what this looks like. So you have seen compute instances being launched on the Catalyst Cloud before, so I'm not going to show that again. I'm just going to specifically jump to our network topology. And in there, you can see that I have Windows compute instance running. If I click on Windows, click on Open Console, in your own web browser, you will have the familiar interface of Windows Server 2012 R2, and ready for you to use. So the interesting thing about Provoke Solutions is that in my opinion, they are one of the few Windows service providers in New Zealand that truly understand cloud computing and know how to do Windows automation in the likes of what we do with Linux on the Catalyst Cloud nowadays. They have a very similar story compared to Catalyst. It's a company that was born in New Zealand, born in Wellington, and now they have offices in Auckland, Christchurch, and some branches overseas as well. Now, granular access control. This was actually a big request from customers, right? Once you sign up to the Catalyst Cloud, you probably want to invite other people from your team to join that environment as sysadmins, developers that have access to the services. Or even create credentials for web applications. My web application will do a backup, and it needs, username and password to interact with the object storage system. So this system this service not only allows you to invite people to join your existing project, but it also allows you to define what services they will have access to. So you can do something that says, here's my web application, it's allowed to store backups in object storage, but it cannot terminate compute instances, for example. Now, in terms of cloud regions, we initially started with our data center in Wellington on the Catalyst House. That was in February 2014 when we launched the Catalyst Cloud as a public cloud, when we were moving away from being a private cloud to a public cloud. And we have outgrown that data center and decided that we would invest on another data center in Porirua. That was launched in February 2015, and that is the ex-Defence Force data center that New Zealand used to trust top secret data to this building. After Porirua, we began some discussions, and this was a year ago in Auckland, saying maybe we'll do a region in Auckland, maybe we'll do Hamilton. What do you guys think? Is there demand, that justifies this investment? And back then, a few customers came to us, and that demand started building up. So I'm pleased to announce to you that the Hamilton region is happening. So we have kicked off that project. We are currently procuring hardware for it. This will be the first data center that we actually share with other people, because our first two regions, they are used exclusively by Catalyst. So what we are doing is a Hamilton in region on the Datacom Kapua data center. And we expect that region to go live in end of 2016. I would say end of November, mid-December is what we're expecting with our current project plan. But this is no longer a discussion about a possibility. Is there demand? It is concrete, and we have acquired the hardware. Now, I guess every talk about the Catalyst Cloud needs to end with pricing, because people always take me to a corner later and say, hey, can you guys really compete with global cloud providers, hyperscale providers in terms of pricing? And what we have found is, if you take your use case and bring it to the Catalyst Cloud Calculator, for example, and put it in on whatever other providers you're considering, we have feedback from customers saying your prices tend to be 10 to 20% plus or minus these global cloud providers. So it really depends on the use case, because we price things differently. Sometimes if you need more compute and less storage, the Catalyst Cloud will be cheaper. If you need more storage and less compute, Amazon AWS will be cheaper. But ballpark, the prices are really aligned and competitive. But what's interesting about this is that similar infrastructure services in New Zealand tend to cost 3 to 5 times more than the Catalyst Cloud. And talking about Windows, you guys will ask how much Windows will cost on the Catalyst Cloud. So Provoke, when selling this image, has set a 20% surcharge on top of our regular compute instance prices. And what that means is that if you're buying a compute instance with 2 CPUs, 2 gigs of RAM for the whole month, on Microsoft Azure, you would pay 206 New Zealand dollars per month for that compute instance. On the Catalyst Cloud today, you will pay $110 for that same compute instance. And just to be fair, on the Azure side of the comparison, that's using the Sydney region. In the United States, their infrastructure cost tends to be cheaper, but in New Zealand, we don't tend to use the United States, so I have used Sydney. And also, they include a little bit of storage in that number. They have probably 40 gigs of storage in there, so you should add maybe another $10 to the Catalyst Cloud price to be fair on that comparison, right? Now, object storage. Some of you may have heard, the existing customers that are here today have heard that we are about to introduce a new version of our object storage system. And the new version, instead of replicating data 3 times within the same data center, which is what we used to do previously when we had one data center, now replicates data across data centers, right? So with the Hamilton region, our plan is to have a replica of your data in each one of these data centers. But it also allows us to cut the object storage prices in half. So as of today, again, the prices have been updated on the Catalyst Cloud website. The new price for object storage is 0.000275 per hour, or 20 cents per gig per month. The calculator is something new. It happened after the breakfast last year here in Auckland. If you go to our website, you will find that there is an easy-to-use calculator that allows you to, these are my servers, my storage volumes, my object storage, and in the end, it will give you an estimate for how much that will cost. We also have a completely transparent pricing model. You will find one page with all our prices listed on the Catalyst website. So very easy for you to gauge how much it will cost in the future. And just to conclude, what should you expect next on the Catalyst Cloud? What are the concrete projects that we are working on right now? Object storage, that's coming to an end. This was a fairly big project for us. So object storage being replicated across regions. And I'm also happy to share with you that we've made significant progress on load balancer as a service and bringing it to production. and we are at the point where immediately after object storage, we'll be able to introduce load balancer as a service. Just to be clear, that's not to say that you cannot run a load balancer on the Catalyst Cloud nowadays. Of course, a lot of customers who run production systems in there have launched compute instances and put some software load balancer in there, like HA proxy. It is just that now we'll have a API call that you can use to say, give me a load balancer, and that load balancer will scale according to your demand without you having to tweak it yourself. So that's it from me. We probably have 2 or 3 minutes for questions, if you have questions.
Can we take questions until we end?
Yes, sure. That's all right. Yeah. Come on then.
Thanks, Bruno.
Thank you.
So, yeah, a couple of fun facts. Catalyst Cloud uses open compute hardware and open source switches to drive costs down. This is the same hardware that Facebook uses in their production data centers. And when full, our 2 existing cloud regions will keep more than $40 million worth of revenue onshore in New Zealand every year. So now I'd like to introduce Edward Abraham, founder and CEO of data science specialist Dragonfly. So Dragonfly use open source technologies for statistical research and analysis, and they're a bunch of incredibly smart people. Have you all got PhDs? Yeah. Dragonfly has been running on the Catalyst Cloud for 2 years, and Ed is going to talk about a machine learning project they're working on at the moment called Kōkako. Welcome, Ed.
Morena tātou. Hello, everybody. Special welcome to Te Hiku Media over there, Peter and Keone, who use this application that we made. So if you want the lowdown, they'll tell you all about it. I'll give you the sales version. Yeah. Dragonfly Data Science. That's where I work. We're a very small company. There's less than 10 of us based in Wellington, and we are a bunch of scientists who have kind of escaped in some way from that system. We're no longer writing as many academic papers as we used to, but we are much more engaged with the problems of the world, and we really enjoy that. So yeah, and we kind of, when we started out, we didn't really know what we did. We knew we were interested in statistics and maths, but this word kind of data science has grown up, and in the last few years we've grabbed it because it fits very well, and that's bringing together that statistics and analytical skill set with an appetite for the software development. And what we really like doing is making that analytics projects operational, so people get value out of them every day, rather than getting some nice presentations and reports that sit on the shelf. And that's what the automation software lets you do. Going to talk about Māori language, and I'm a Pākehā, and I was interested yesterday. Nat Talkington posted this little tweet on social media there, and he's hopping on a plane in San Francisco. He's coming back to New Zealand, and he sits down in the seat, and they say kia ora, and I guess he has a little emotional hit of that great feeling of that he's coming home from New Zealand, and he tells us all about it. So this Māori language is really important to Māori and their culture, and it's important to all New Zealanders, and it's something that we should all love and look after. So we were approached by Te Manga Paho, who are a Māori broadcasting agency. They fund the network of iwi radio stations, and asked to develop an application to help them monitor the amount of Māori language that was being broadcast on their network. Their goal is to increase the usage of Māori language across New Zealand, and they're particularly focused on the community of more fluent speakers, but there's a lot of diversity in that community, and they talk about the right shift. They want to expose more people to Māori language and improve their fluency. So yeah, at the moment, around 2% of New Zealanders are conversant in te reo, and there's a substantial expenditure to increase the use of language. So in the recent budget there was 34.6 million of new money allocated to that, I noticed. So the government is making that investment, and it's interesting to see that money is being well spent, and that's where the monitoring comes in. There are around 21 iwi radio stations around the country. These guys, Keone and Peter, they're from Te Huku, which is up in Kaitaia. And so they tend to be radio stations that serve their local communities. And their funding comes from government and also from advertising and other revenues as radio stations do. But that government funding comes with the requirement that they broadcast from the 1st of July, that they broadcast 10.5 hours of Māori language content per day. And that can be in te reo or in Māori music. The way that's been done in the past is through a manual process. They tended to have they would fill out a programming schedule for the day, and that would get sent down to Te Manga Paho, who would employ someone to review that schedule, dive into the archives, find the files, put the headphones on, listen to the audio, and see if they're talking in Māori or English, and then fill out a spreadsheet, summing that up. It was quite an inefficient process, not something that classic. It was a classic problem that they employed a specialist in Māori language, and he was spending all his time looking after the quantity of monitoring the quantity of language which has been spoken. So he ended up doing this very big component of his job that was very functional, and he was really keen to be shot with it and move on to more interesting things. And the other problem with these manual processes is that they're slow. By the time that information is ready, it's not really of any use. It was being used by the government for that monitoring purpose, but it wasn't available to the stations to help them running their own systems. So that was the challenge, was to take that manual process and automate it and make it up to date. So yeah, how does this work? I'll just give a little bit about that, and then we'll just have a wee look at the application and show what we've done. We're using machine learning, and the idea is that we manually tag a training set of audio by whether people are speaking in Māori English. That's fed through a neural network, and the neural networks are little models of kind of biologically inspired, based on the human brain. And the idea is that you kind of don't really know what goes on inside there. You feed them your classified data, and it learns the patterns in the data that are associated with those classifications. And then when you apply it to new data, it will automatically classify it for you. The nice thing about them is it's a completely general technique, so you could apply that to any. The method that we used, you could apply it to any streaming data. So that could be, it could be faults coming out of the Catalyst cloud. It could be a video that someone was interested in, or any kind of large data source that you need to put labels on it so you can access it and see what's going on. Yeah, in this case, it learns to distinguish the characteristic sounds that of Māori and English. So, in particular, in Māori, there's no S sound. So, here's S's. Chances are that speaker is talking in English. I put this little picture up here of me tying a recorder to a tree. It's a wee foundation story for this project, because we were interested in the similar problem of monitoring birdsong in the forest. And in this case, this is a project where they'd introduced kiwi into the bush, and we put out recorders to count the kiwi. And we did all this work, and we never really managed to get funding for it. But luckily, someone at Te Manga Paho heard about it and came to us and got the conversation onto Māori. So, and that's flourished. So yeah, but that's where it started out tying things to trees. And in terms of implementing in the cloud, just specifically the radio stations are archiving all their content with Ngā Taonga, the film archive and media and film archive in Wellington, and they've got a Windows system, and we run a script on that when the files are copied in there, it opens up a port into the Catalyst cloud and transfers that audio into their object store. And for us, the Catalyst cloud made great sense because the source of that audio is in Wellington, and there's this substantial stream of it that we didn't want to have to pay international traffic on. So shifting it across town to Catalyst was really made a lot of sense. We've taken a microservices approach, so there's a number of tasks that need to be run on the audio as it comes in, and we have a lot of separate Docker instances, so little virtual machines essentially that are each responsible for doing one thing. In fact, the processing the audio is quite lightweight, so we have a single instance that they're all sitting within, but we've kept it really modular to help us scale it if we need to. It's very easy then to pop one of those little services off onto another server if we need. We've got a Postgres database there, so those services, they're doing their work and they put that information into the database. And then there's a web application that's built in Image.js, so it can access that data through an API. Yeah. And I mean, the key for us about the cloud was it really looks after the things that we don't want to have to think about. So we're a small team, and we've got those development skills, but we do like to go home in the evenings and not think about work too much. And we're, this is making the transition from kind of project-based work into an operational system, and we don't have to be responding to hardware faults and all that kind of stuff, right? So delegate all that to Bruno. And the other thing that's really important is it forces you to interact with the cloud. It forces you to automate your deployment of your software. You need to be able to script things and have them work. And that's a really good discipline to put across the whole project. So having done that, then development, operations systems become a lot more straightforward. So, and the third thing, and Bruno raised this point, is that keeping it local is really important for us. There's the in the Māori community, in particular, there's a real feeling that they want to know where that information is and who's looking after it. That custodianship is important, and for government agencies as well. In this case, the clients are government clients. That's an issue for them. There's no private data in here, but it's that sense of ownership, and more practically for us is the fact that we have personal connections with, we know these guys. So that has helped from time to time when we've been able to get help when we need it. So yeah, I will just give you a little demo, show you what it is.
There you go. It's that one. And it's right. You need.
Yeah. That's right. Try the mouse.
There you go.
Yeah.
Hold it.
So this is a feed coming in from the Huku media, and the last updated. I probably need to refresh it. The last updated at 6 in the morning. The colours here are showing the classification. Red for Te Reo, blue is the language of the Queen, and the purple colour here is Māori music. So we've got another system that does fingerprinting on that to see what they're speaking. So what we've done is taken that kind of timesheet based approach and produced something where the station managers can come in, they can turn up to work at midday, and they can pull up the console and they can see what's been happening on their station that morning and the day before. Yeah. So just let's have a look at a little chunk somewhere. Find a bit where. So yeah.
Ngā take o te tai tokerau.
Ngā mihi o te ata kia koutou katoa e whakarongo.
They're talking Māori. If we hold over here, get a guess.
But otherwise, yes, the league's going good. I'm just trying to think. Naro mai to Jim Larkin, who's progressing.
Wait, so yeah, you can see that's working, even though that's not the kind of audio you'd want to push through a speech text processing application. The quality is variable, all sorts. No, and then over here, I think we've got some. Yeah. So it's taking that content stream that's flowing through, splitting it up, and yeah, letting the stations see what's going on their radio stations. So yeah, that's yeah. So yeah, any questions for Bruno or me?
So everybody have questions? Go.
Can you pull out and track keywords?
No, it's not a word-based system, and that's going to be. I think there's a lot of interest in developing speech recognition for Māori, which is tracking the words. All it is doing is listening to the sound of the language. Yeah, we haven't got a language model yet for Māori to use the speech recognition.
Besides the beautiful user interface of this application, one thing that I like in particular about what Dragonfly have done is the native use of cloud computing constructs. The fact that you have all the audio streams from radios going straight into object storage, the compute pool running in parallel here, digesting that information, and then again streaming the audio straight out of object storage to the browser. So congratulations. Not many companies in New Zealand are doing what you guys are doing. Yeah.
Have you thought of any other uses?
Yeah, in fact we've got this kind of we need to. It's a classic problem. We've done something. We're a services company. We've done something really great, and now we've got to work out how to get resources to push that further. So even that music classification is another. It's not another digital fingerprinting, and there's been a lot of interest just in that application. There's lots of people want to be able to identify what sounds have been played and streamed. So, but yeah, we'd love to work with other communities around the world. That'd be super exciting. And go off to I don't know, Scotland, deal with the Scottish Gaelic community. That'd be great.
And the work project you've mentioned,
yeah,
would that be using the same technology?
Same technology. Yeah, that's right. That's right.
Anyone else got questions? Questions for Bruno? Make the most of him, he's not here that often. Okay, thanks everybody. Thanks very much for coming. Lovely to see you all. There's still some food left over, and we can go up to the other room and have some more coffee and some chats. So great to see you all. Thanks very much.